Thank you for watching EMEE6002 Sustainability and Climate Change. This section is about wind energy. The concept of wind energy is very simple. We simply convert the kinetic energy of the flowing air into the kinetic energies of the rotating wind turbine and then generate electricity energy. There are two types of wind turbines. The first type is very popular. You can easily find in many installations, for example in Nana Island in Hong Kong. So there's a horizontal axis and the wind turbine will rotate in a vertical plane. So this type of wind turbine has to facing the wind directions in order to maximize the efficiency. On the other hand, there are some other wind turbines where the rotation axis is vertical. So in other words, the wind turbine will rotate in the horizontal plane. And this type of wind energies can accept winds from all different directions. So this installation is suitable for the installations in the place where wind directions is not stable, sometimes from the north, some from the east, and so on. So this is the basic structures of a wind turbine. There is a wind turbine blade, and inside the wind turbine there are some gears, motors, and generators. And the wind energy that we can harvest from wind is given by this equation. And according to the motions equations, when we have an initial velocity of u and the final velocity is v, then acceleration is equals to v squared minus u squared divided by 2s. S means the distance they travel. So if the initial velocity is 0, u is 0, then acceleration is equals to the final velocity squared divided by 2s. And according to the kinetic energy equations, kinetic energy is equals to half mv squared mass multiplied by the square of the velocity. Therefore, energy divided by time, which is the power, is equals to differentiate of half mv squared by the time t, where the mass is the variable. So imagine we have a cylinder of air travel through the wind blade. In a time t, the wind travel at a distance x. So dm dt, the change in mass by time, is equals to mass is equals to density multiplied by the area of this cylinder circle multiplied by dt, which is the time traveled by the air within this delta t period. So dx dt is in fact the velocity of the wind travel during this period of time. Therefore, if we put this dx dt, which is the velocity of wind, into these equations, so we will have dm dt is equals to density of air multiplied by the surface area multiplied by the velocity. So in other words, in 1 second, the distance traveled by the wind will be v, because v is the velocity. 1 second means the velocity traveled by the wind, say 5 meters per second. In 1 second, wind traveled by 5 meters. And then multiplied by A will be the volume, and then multiplied by the density will be the mass of this cylinder of air. So if we put this power is equals to half mv squared, right? M now is given by this. So m multiplied by area multiplied by v, and then another v squared. So we will have power is equals to half density area multiplied by the velocity to the power 3. Okay, so therefore, that's why we have these equations. Compare with the equations that we can find from the experience, these two equations are consistent. However, there's a factor that affects the efficiencies of the wind turbine, and this is the power efficiency. And usually it's talking about 40 or 50%, and according to the Dex law, it's not possible for this power efficiencies exceed 59%. Okay? So this is the maximum power efficiencies that can be achieved. And the best limit is that the wind turbine cannot operate at this maximum limit. And in general, the power efficiencies of an ordinary wind turbine is about 35 to 45%. In reality, only a very small fractions of the wind energies can be harvested by the wind turbine. Let's talk about 10 to 30%, and the equation is given by this, where Cp is 10 to 30%, which is the power efficiencies. So we will have these equations. The power of the wind energies is equals to Cp is the coefficient of the performance, and then this mu is the conversion efficiency multiplied by the area and the density of the air, and then velocity to the power cube over 2. The reason why we have V to the power cube is because according to the kinetic energies, E equals to half mv squared. So there are 2 V there already. Another V is which affects the volume, and in other words, the mass of the air. The faster the wind blows through the wind turbine, more air will pass through. So the mass is also proportional to V. This is the reason why they have another factor V. So altogether there are 3 V that contributes to the equations of the power of wind energy. Let's see this example. If the blade length is 52 meters and the wind speed is 12 meters per second, the air density is 1.23 kilogram per meter cube, and then the power efficiency is 40%. So we put this number into the equations. The area of the wind turbine will be given by half R square. So we put the numbers here. A is equal to half R square, R is 52, so the total area is equals to 8,495 meters squared. And then if we put the other numbers there, the air density, and this is the wind speed V, and the efficiency of the power conversions 40%, then the power output is equals to 3.6 megawatts. There are some software that can help us to design the wind turbine. For example, you can go to this link, blade calculator 2006 software.informer.com. So when you enter the number of blade, the TSR, which means the speed of the blade tip, and divided by the wind speed, which is called the tip speed ratio, and the blade efficiencies and the radius and so on, then the system can help to calculate the energy output of this wind turbine. There's another software contributed by NI, National Instrumentations, that can also help you to calculate the energy output of a wind turbine. So you can go to this website to have a trial. So wind energy is nowadays very popular and become more and more important in the development of renewable energy and a clean city. So there are more replacements of the fossil fuel power plant by the wind energy. In some countries, they do not develop fossil fuel power plants anymore, and not neither nuclear power plants, and they put more focus in wind energy.